is out, your calculator is out, and you're working. Did you get it already? You need to fill out your water. Here you go. Calculators.
Oh, it's right there.
Here, grab one.
I think I need one. Man, no. I think you. Oh my God,
Yes, sir.
That's right.
I should not hear talking. I hear the sound of a silent pencil on a silent paper. Yes. What did we do on Monday? We learned, I just remember when we were over at the board. Remember before? And I said on Monday, we learned lesson 1.2 part 1 and then continuing that today.
Were you here?
No.
Was I here?
No, she wasn't. I wasn't here.
Right, but we just talked about what we did on Monday, we're continuing lesson 1.2.
Yeah, okay.
I recorded the entire lesson on Monday and put it on YouTube. So if you watch it, it's literally like you came to class. Yes.
What are we doing tomorrow?
Okay, I just went over that too. Were you guys not paying attention?
Oh,
I'm gonna say it one more time, and the next person who asks me is going to get a very not as friendly reaction. Today, we are continuing lesson 1.2. The homework is due on Tuesday. Tomorrow, we'll finish whatever part of 1.2 we don't finish today. Then your take-home quiz is also due on Tuesday. She's filling her water bottle now. Faith, focus. Yes, ma'am.
That was the loudest sneeze in my ear I've ever heard. I might be deaf.
You chose that seat. Carmine's like, okay, I'm good now.
I might be deaf. I might be a little deaf.
That's okay.
Can I take this out because this is what's
Yeah, I
getting
know,
me
it's a
stuck.
pain. Yeah, it gets stuck, yeah. No.
I can make it.
No, you can't.
You don't know that I can do anything but put my mind to it.
No, you can't.
Yes, I can. Yes.
Yes.
Rachel probably if I can.
Okay, thank you so much for asking for help instead of just chatting and causing distractions. Okay, so what property jumps out at you to get this morning started? Starts with a D. Yeah, starts with a D. Brianna? Distribute. Okay, so you're gonna draw your arrows for distribution. You can use a calculator to solve all this. If you guys accidentally find yourself with one of my calculators outside of my classroom, please just bring it back. I'm not going to accuse you of stealing. I know sometimes you try to pack up your stuff and everything just kind of gets thrown in your backpack. If you find it, please bring it back. Yes.
Here, take my calculator.
No.
It's okay, you're getting my humor. Did you get it?
None.
Okay. Hold on, I was going to eat. Yeah, you distribute to this, and that, and then you also distribute. Oh, sorry. No, but why? Do you have a question? Yeah. Grayson, focus. Yes.
Wait, is that right? We need to distribute.
Yeah.
After that.
Oh, you weren't here on Monday, so that's why you don't know. I'll go over it.
Oh, okay. I went for like half the video and then I changed.
Oh, you did?
I was here.
Yes.
I see it. a negative 10 times 5z is a negative
Wait, hold on.
50. A negative 10 times 0.8 is a negative 8. All right, guys, I think we're realizing that some even, what? You weren't here.
This is real.
Okay.
I wanna know, that's why.
Okay, you're just excited. You're eager to learn. That's great.
Yeah.
Yeah. Okay. Hold on. I can see a hand. You don't need to call my attention to your hand, okay? I think a lot of us are noticing that yes, we're distributing, but you have to follow all the rules for your multiplication of positives and negatives. I'm gonna go over this with you guys because I think we're all having a little bit of trouble. It's been 2 days of hurricane, so we're going to. Do you need what?
I'm good.
Okay. 100 times z minus 2 equals negative 10 times 5z plus 0.8. And then, yeah, you distribute. If you are having trouble knowing where to start with something like this, look at the way it's set up. If you have a number outside of an expression inside of parentheses, that should come to your mind to distribute. Or as somebody said, the rainbow thing. That also works. If you want to call it the rainbow thing, go for it. All right, when we distribute, what do we get here? Somebody work with me here. Yes. 100z minus
2.
minus 100 times 0.2, which is
Negative 20.
20. Okay, minus 20 or negative 20. Next, this is where a lot of people were getting tripped up. Negative 50z. Negative.
Because the 10's negative.
The 10 is negative, the 5 is positive. If we're multiplying a positive and a negative, it is a negative. 10 times 5 is 50. Negative 50z, and then what is it, negative or positive?
Negative.
Negative. A negative and a positive, so it would be negative 8 or minus 8. Remember, negative 8 and minus 8 are the same thing. A negative acts as subtraction, a subtraction acts as a negative. Yes, just be careful. You might want to go around with the phone. All right, now I have a lot of questions. Where do we go from here? This is what we learned about on Monday. This lesson, if you are still confused about it, is also on YouTube. I even have the date on the title. So
What you do?
what do you
Add 50z to the 100z. So that it's on one side.
Add 50z
And then that becomes 150z minus 20.
on both sides. That goes away. Now, did anybody solve it by taking care of the numbers first? Because there's nothing wrong with that.
I did.
No.
I started to, but it confused me.
Okay, there's nothing, whoops.
I also changed the numbers around.
Minus 20. Can I do the rest?
What'd you get as your answer?
Can I do the rest?
0.08.
That's correct. Why is there so much noise? Hold on, guys. Grayson, you can continue. We have 150z minus 20 equals negative 8. Go ahead, Greg.
And now what you do is you add 20 from the 20 and then the 8 and then negative 8 plus positive 20 is 12.
Good. So we have 150z equals positive 12.
And then you divide 12 by
How's it positive 12?
yeah, it's a
Because a negative plus a negative or a negative.
Who said that? It's okay.
I remember that.
Okay. Our rules of adding a negative and a positive number. You take the difference of the absolute values, which is 12, and you take the sign of the higher absolute value, which is 20. That's positive, so it's positive 12. And yes, Gray, divide by 150.
And then the answer is z equals 125.
What?
How did you what?
12?
12 divided by 150?
Yeah. I don't
Hold
know.
on, let me fact check him.
I did not know.
150 divided by 12.
Yeah, 150 divided by 12.
Pause. I got this, guys. 12 divided divided by 150, so you put the 12 in first.
Like in like the box?
Yeah, the 12 is inside the
I put
house.
150 in the box.
Yeah, we don't wanna put 150 in the box because our numerator is the guy that goes, you know why you got confused? Because you're like, but 150 is bigger, so 150 should go in the box.
No, I just always thought it was like that.
Oh, that's kind of scary. Yeah, the numerator goes inside the box, even if it's the smaller number. We are dealing with decimals now, okay? Decimals and fractions. All right, are we good?
No.
Yes.
No, give me 1 second.
Okay.
I don't know.
Did anybody attempt B and possibly get
Oh,
it?
I did.
Angelina, did you get it? And Lex, what did you guys get?
I got D equals -5.
That's
I got
correct.
D equals 5.
5.
Yeah.
Jacob
Oh,
got it.
This is
so
what I
close.
got.
So close yet so
Miss-
far.
That's not right.
Yeah.
Wait, let me
Jacob
Oh,
got
I understand. I know.
He got it?
it.
Do you?
Got it. I didn't.
Oh, he
Simple
did.
mistake.
Yeah. It should be
Leave
simple
him a
and
little
why did you
present.
make it? Why did you
Yeah.
make it
Can we leave him a little present?
Oh, I think Jacob took
Math.
it.
You can give me a present. Oh wow.
Did you can have the opposite of this because you got the opposite of the right
The
answer.
opposite of that would be a peanut M&M.
No. The opposite of this would be like something healthy. So you get like
Celery.
You get a raisin.
Can I have an
Yes,
apple?
you get celery.
Do you have an apple? Tomorrow?
Actually, I wouldn't mind that.
Celery is horrible. Unless you like peanut butter and. I got B right?
All right. Angelina, can you walk me through B?
Yeah.
Yeah, just give everybody a second because they're being way too noisy. All right, go ahead, walk me through this.
So, you distribute.
Boys,
You distribute on both sides.
good.
We have to write this one down.
I say that's a good idea, yes. Go ahead.
It's 10D.
Good, I'm gonna actually write it out for people who get confused about how to do this. So we're distributing the 5/8 times 16D. I know you guys think it's just this tiny little giggle. I hear everything and it's distracting me from what I'm supposed to do. For you, okay? It's all for you. 16D over 1. Now that is what we're doing when we're distributing, right? We are multiplying. So, I like to cancel. If you want to multiply 5 times 16 and then divide by 8, go for it. I cancel, I make things simple. I don't use calculators when it's this simple, but if you like to use them, go for it, okay? So then I have 5 times 2 is 10, so I have 10D. Over here, I multiply,
How did you get 10D?
I just did it.
If you want a calculator.
So 5 over 8 times 16D over 1. Because 16D is a whole number, right? So I put it over 1. And then I canceled my 16 and my 8. I divided 16 divided by 8. Or I should say I divided each of them by 8 because it's the greatest common factor. Do you remember canceling fractions? Okay. 8 divided by 8 is 1. 16 divided by 8 is 2. Now I have 1s in my denominator. The denominator goes bye-bye. I have a whole number. 5 times 2D is 10D. You get it? Okay. Next, I have 5 over 8 times 24 over 1. I'm going to cancel again. 24 divided by 8 is 3. 5 times 3 is 15. Is it positive or negative? Positive 15. See how scary fractions look, but how simple they become if we're just careful and we follow our fraction rules for multiplying. We follow our positive and negative rules, which we didn't have to deal with here because everything was positive, but we do have to deal with it here. So 6 times D is 6D. 6 times negative 1 is negative 6, and then we have a positive 1. What jumps out at you as the next step to get?
Add the ones.
Yeah, we would combine our negative 6 and our positive 1, right? We combine like terms. And we get negative 5. Good, so I have 10D plus 15 equals 6D minus 5. Angelina, what's next?
You combine like terms, you combine the like terms from both sides.
Yeah, so I'm trying to be careful with saying combine like terms. we want to use the word algebraically. That reminds us that when we're going across the equal sign, we have to do the opposite of what's happening, okay? Because when we're just combining terms, we're just adding them together. We are combining, so I sometimes say combining across the equal sign, or combining algebraically, doing the opposite. So yes, we identify like terms on opposite sides of the equal sign. Does it matter which one you start with, your D term or your numbers? Does it matter? It doesn't matter. It really, really doesn't. So what did you do?
I subtracted 6D from 10.
Okay, minus 6D, cancels that out. Minus 6D, and I get 4D plus 15 equals, what is left here? It's getting messy. Negative 5. Okay, and my last step, or almost last step, Bo. Yeah, subtract 15. And yes, it's getting ugly with all these negatives. Follow your rules. Brianna, what's a negative 5 and a negative 15 added together?
Positive 20.
So close. I loved the confidence so much, but it is a negative 20 because when we're combining negatives, this is how I remember that rule. If you need help remembering why it's negative, think of this. A negative 5, think of that like money. I owe Bo $5. I owe Jacob $15. I owe a total of $20.
Divide and multiply.
Yes, that they cancel each
I always
other.
get those mixed up.
Yeah, okay. All right, so we have 4D equals negative 20. What do we do? Divide by 4 on both sides. We get D equals negative 5.
Hold on.
Thank you, I will not erase it.
How did you
Did you copy down anything here? You want to see?
Oh, never mind.
That's really important. Does anybody need a calculator moving forward?
Tell it does.
You guys good? Thank you. Thank you for being quiet while we're just waiting for people to finish writing. Then we're gonna move on to bigger and better things. So before I move on to the next slide, we so far have been solving for a variable. And we're getting some sort of answer, right? Like D equals negative 5, Z equals 0.08, X equals 3, T equals 92. How many solutions are we getting when we're solving for a variable? We're just getting one. So far, we have been solving for a variable and just getting one solution. Do you get what I'm hinting at?
Oh
Right?
Please, no, I hated this.
Oh, I promise it's easier. The next problems are actually easier than these problems.
Are we getting
Yes.
so complicated?
Are you sure?
I am so sure. Okay, ready? What the what? Don't worry about the drawing. All they did was draw it out. You know how I'm all about drawing out problems? I'm actually not fond of this because I think it looks more complicated. What I want you to notice about this equation, it looks just like the ones that we've been doing. But there's gonna be a difference. There's not gonna be one solution. And it doesn't mean you have to solve it over and over until you find more than one solution. Girls in the back, focus up here, please. Even though you're being silent, and it's distracting for me that you're looking at each other and not up here, okay? So we have a very simple equation, what we've been dealing with before. Oh yeah, we gotta distribute, no big deal. It says, what is the value of X in this equation? Well, I want you to do something for me. You know how I don't like you guys to do anything in your head? I want you to write it all down. Well, I want you to not listen to me just for these 30 seconds. Mentally distribute that in your head and tell me what you notice, like a light bulb. Yes?
Oh, wait, I'm just doing it.
Oh, I don't want the answer. I want you to mentally distribute this and tell me what you notice.
The numbers on each side.
Yes.
What?
the numbers on each side, the expressions on each side are exactly the same. If you distribute this, now go back to my original rule where you show everything, okay? I'm sorry, I'm getting like confused faces. I'm gonna show you how it's the same. And then I'm gonna show you what that means. 4x what?
4x plus 6.
Good.
Oh, that's right.
Yes.
Oh.
But what I was asking was, after you do that in your head, what do you notice about this equation?
Oh, it's the same.
It's the same. Very good. So we have 4x plus 6 equals 4x plus 6. Now, before I go ahead and like work my algebra magic here, I'm going to show you a baby equation.
Baby.
Wait.
Like what grade?
Baby equation time. How about 2x equals 2x?
That's
Give me any number for x. Remember, we're doing baby equations, so let's do something really
1,
easy.
4.
I heard a 3, let's do 3 and 4. Okay. 2 times 3 equals 2 times 3. Hey, that value for x works because 2 times 3 is 6 and 2 times 3 is 6. Okay, now let's try if x equals 4. 2 times 4 equals 2 times 4.
Same.
So it's still true.
Same.
Give me like a really crazy number for x.
100,456.
Okay, 2 times 100,456 equals 2 times 100,456.
100,456.
Right? It doesn't even matter because it's going to be the same. It's going to stay equal, right? So what we are noticing is when the expression on one side is equal to the expression on the other side, it doesn't matter what the value for x is because x can be anything, any real number. You can plug any real number in. So what does that mean for you when you have a homework question that says, what is the value of x? Carmine, pay attention, okay? What is the value of x? You have to write every number you can think of in the whole number world? No, that would be dangerous because you would die before you finished, right?
Huh? It's like just written an infinity symbol.
Just go.
True, right?
Bam.
I love that he just said that. Shh, I love that he said write an infinity symbol. Because the word infinity actually has a lot to do with the answer to this problem. When we actually solve it, yes, we see that there are infinitely many solutions. Infinitely
I didn't even see
many
that.
solutions. I know, you're just using your brain, it's good. Okay, if I were to actually try to solve this, like let's say I didn't even notice that they were the same. I'm just like, oh, I gotta solve algebraically because that's what Mrs. Like told me to do. So I'm gonna minus 6 on both sides. And then it makes it all go away, and then I have a 4x equals 4x, and then I'm gonna subtract 4 on both sides, and then I get, no,
X equals 0.
what's 4x minus 4x?
0.
0 or 0x.
So just
If I have no x's, how many, what do I have? If I have nothing, right? 0 equals 0, okay. Is this a true statement?
Yeah.
Yes. So 0 could be a possible value for x. Let me solve it the other way, where I, here, 4x plus 6 equals 4x plus 6. I'm just doing it over again. Let me do it the other way, where before I take care of my 6's, I take care of my 4x. Minus 4x, minus 4x. Oh no, they all go away. Head up, please. They all go away. And now I have 6 equals 6. But my x values are gone. This is called an identity. Please disregard the fact that the book has a typo that says it's called an identify. Identify is not even a noun.
We should see why.
Identity book, that's what it's called. Identity, not identify. Please disregard that.
Identify.
It's called an identity because it's like a 0 looking in the mirror and seeing another 0. It sees its own identity. It's like a 6 looking in the mirror and seeing a 6 looking right back out. It's identity. So we call this an identity Because it has infinitely many solutions for x. It doesn't matter what you plug in for x on one side, if you plug the same value in for x on the other side, it will be true, true, true. Good, head all the way up. Or you can stand and dance around if it's gonna keep you awake, okay? Because this is interesting stuff, you don't wanna miss it.
Let's not lie.
Oh.
This is not, this is scary, not.
Sometimes scary can be interesting too. It's just about
If
perspective.
it's like a haunted, like.
This is like a haunted house. A haunted house of algebra horror.
We scare because we
I scare because I can.
worse than we should make a haunted
We could spend more time talking about how hard this is, or we can go on to the next. Practice makes perfect. Very good.
There's no such thing as perfect.
Now, I don't expect perfection, but I like practice makes progress, okay? So the more we practice, the more we're going to make progress, okay? So, what vocabulary did we learn just now? No, identity. It's like a number looking at itself in the mirror going, oh my gosh, you're me and I'm you, we're the same. That means the value of x has infinitely many solutions. Now let's look at something crazy. What is it?
I am
Reading
sure.
the book, technically, they're teaching us the wrong stuff.
I know, you guys have no idea how many mistakes I found in the book already. Don't worry, one of them that's coming up tomorrow, I'm gonna make an extra credit for anybody who figures out why the book is wrong.
Sometimes government websites, like I copy and paste in the word spelling, are like, dude,
I know,
your
it's like-
government website.
I know, it's embarrassing. So let's just focus on the good stuff, okay? We'll catch the mistakes, we'll learn from them. Here we go. Here we go. What is the value of x in this situation? You're gonna find out, I know it kind of maps it out for you. You're gonna find something really weird, okay? You're gonna find something really weird.
What?
Watch, let's work this out together. Okay, they distribute, right? The 2 times 3x is 6x, the 2 times the 4 is positive 8, okay? Then they're like, okay, I'm gonna take, and they're like, ooh, there's a 6x over here and a 6x over there. Does that mean it's gonna be infinitely many solutions? Because if I take away 6x from this side and then from that side, the x's go away.
It has to be the same.
Yeah, the x's go away if you take away 6x from both sides. But then you're left with a negative 5 equals 8. No, son, it does not equal 8. Negative 5 does not equal 8, which means there's no solution. It means any number you try to plug in for x, if you try to put in the same number for that x, it's never gonna work. So this would simply be no solution. Yes.
Isn't that like equal with the dash saying non-equivalent?
Yes, not, it just says not equal to. Or as I like to say, non-son, okay? Negative 5 does not equal 8.
So like if a question like that was on the test, would we just write like -5 equals like?
What it would give you, if you had it on a test, it would give you multiple choice, and it would say, it would either say, what is the solution, and then it would say x equals, and then if somebody did it wrong, they'd be like x equals 3, and then they mark it wrong. Or another option would say infinitely many solutions, or it would say no solution, and you would choose no solution. Okay. Do you guys agree that this is like a little bit easier than the first examples? Because it's much easier to be like, oh, that's the same on both sides. It's an identity, infinitely many solutions. Or this is like, that doesn't equal anything, so there is no solution, right? Yes. I would like you guys to try A, and if you're feeling crazy, also try B.
This is already.
He's going to look at that. There is absolutely no talking. Go ahead. Yes, we are trying A and B. Be careful when you distribute your negative. Distributing a negative is basically like multiplying each term here by a -1. It's basically saying, no, okay, just no. It's basically saying, take whatever sign these have and do the opposite, okay? The negative is negating each sign. And then I also want you to think about what property can be used without actually solving algebraically. After you distribute, I want you to tell me what property can be used to show whether this is an identity or not. Hint, hint.
Wait, I'm sorry.
It's okay.
I wasn't listening because
Okay.
I was trying to write it down.
It's okay.
What?
Okay. Did you hear my spiel about the negatives? Okay. A negative on the outside is basically like having a -1
Oh, yeah.
being multiplied. Okay, so you understand that, right?
Yeah.
The other explanation is it's kind of like saying do the opposite of this sign and the opposite of that sign, and that's all it is. It doesn't change.
Not identity.
It's an identifier.
So,
According to the law.
yeah. So, what I'm asking you guys is you can solve this algebraically. Did you already finish?
Yeah. No solution? Oh.
Look, because
I know what it is.
Adding.
Right, and what I'm asking you is, can you tell me what property we can use? Here's my,
Associated?
Distribute, switch.
what, what?
Commutative.
Commutative, look, I'm moving. I can move two terms. Commutative property of
Multiplication.
addition. You guys want me to just show you?
Please.
Okay. T minus 27 equals, tell me to just what I distribute that, what would it be?
-1.
-27
Yep,
plus t.
plus T, very good, plus T. I write my T's super fancy when I do math so they don't look like plus signs. All right, they kind of look like anchors
just
instead.
make that.
Silence, silence, too noisy. All right. Now, they don't really look like, it almost looks like they're trying to trick you, right? Like, oh, you want me to think that you're the same, but you're not. Or are they? Or are they? Can anybody tell me how to use my, is somebody down?
Yeah.
Oh, on the outside? Oh. Come on, come on, come on, come on. It was not off. Remember this was off. Oh, now you're going? Okay. All right. Tell me how I can use my commutative property of addition. Carmine, can you do it?
So basically, T minus 20 is the opposite, basically.
Yeah, tell me what I can move around to make it look exactly the same.
So basically, you could put the -27 on the right-hand side.
Yep.
Then just basically switch it over.
Yep, because if I am technically combining these, I can't actually combine the terms because they're not alike. But if I am combining them, I don't have to combine them together, but I can move them around because of the commutative property of multiplication. Anything that is being added together can get switched. So I have T, positive T on this side, and I have minus 27 on this side. T minus 27 equals T minus 27. Is it an identified?
Yes.
Wing, wing, it's an identity, very good. So if you were to actually try to solve, if you're like, oh, what if I don't remember the commutative property of addition? That's okay. So just solve it. Go, okay, well, I'm gonna add 27 to this side, I'm gonna add 27 to this side. Uh-oh, everything's canceling out and I'm left T equals T. It's like looking in the mirror and seeing a T staring right back. It's seeing its own identity. That means whatever number you put in for T will be T. And every real number will work. Yes?
So I was paying close attention to your word for identity. So not this one, not the last one, but the third one.
Mhm.
It's an identifier.
I know it was a joke. It was a joke, and you caught it. Very good. It was a joke because the book was saying identify. All right. Did you get B? You want help? Okay. How are you supposed to multiply? That's a good question. All right. Did anybody have any success with B so far that they think? Okay. There are two ways that you can go about this. One is you can go ahead and distribute just like this. You guys get so freaked out when you see fractions. The other, they scare because they care, okay? Just like me. I don't need the side noise, my voice is getting very tired at the end of the day, okay? Next time, lock the door on your way out, and then, yeah, okay. So, but if you wanna skip the crazy distributing on both sides, do you see something that you can do to simplify it before we distribute? What's that? I can't hear you. Yeah, divide by what? Good. Divide both sides by 16. Watch what happens. Because I just noticed that 96 can be divided by 16 and get a whole number. So that's what I'm doing here. Because I want to make it easier. Because then if I cancel out my 16, then I don't even have to distribute on this side, and it's nice and simple. If I divide by 16 over here, you guys can use your calculators. 96 divided by 16 is what? 6. So we get 6 is now on the outside of the parentheses times negative m over 2 plus 1. And yes, I'm still going to have to distribute on this side, but it's not going to be quite as scary, right? You could just distribute from the beginning, but your numbers are going to be big and ugly. So let's distribute here. I have to distribute my 6 to this and to that. And you're like, ew, how do you distribute a 6 to this negative m over 2? Just like this. 6 over 1 times negative m over 2. You just set it up like a regular multiplication problem. If one of them is in fraction form, make both of them in fraction form. That's it. Then you can multiply if you want, but again, I like to cancel when I can. Do you guys know about canceling, right? Or did you get, you got handed a calculator and you thought maybe I'll just have a calculator do all my work? I have 3 times a negative m, which is what? Negative 3m. So distributing will get me a negative 3m plus 1 equals 4 minus 3m. Oh, minus 3m on that side, minus 3m on that side.
So you're basically dividing.
Oh my goodness, who just said that? Great job. She caught my mistake. Did you know I had a mistake on one of my videos? I had to take down the whole video because there was a mistake on it. So please catch my mistakes when I make them. Okay, 6 times 1 is 6. All right, now we see a negative 3 on this side and a negative 3 m on this side. What happens? Well, let me add on both sides. And uh-oh, is that where you were uh-ohing? Okay, uh-oh, 4 equals 6. Huh? No, son, it does not. 4 does not equal 6. So what does that mean for the solution? No solutions whatsoever. And we are done. Please stack chairs. And